Now 7.21. Obtain the resonant frequency and Q factor of a series LCR circuit with L equal to 3 Henry, C equal to 27 microfarad and R equal to 7.4 ohm. It is desired to improve the sharpness of the resonance of the circuit by reducing its full width at half maximum by a factor of 2. Suggest a suitable way. Now see, inductor, that is with inductance 3 Henry, capacitor, that is with capacitance 27 microfarad, so that is 27 into 10 raised to minus 6, and resistance connected, that is 7.4 ohm. Now resonant frequency, that is 1 upon 2 pi root LC, substitute pi 3.14 L 3C 27 into 10 raised to minus 6, and you will get the answer. Then after Q factor, that is 1 by R root L by C. So 1 upon R, that is 7.4, root L that is 3, C that is 27 into 10 raised to minus 6. Solve this one, you will get the answer. Now, if you want to improve your Q factor by the factor of 2, means new Q factor, that we want 2Q. Clear? So now here L and C that we keep constant, we can change R. So new resistance 1 upon R dash into root L by C. So you will get the value of R dash. Clear to all of you? So here we will get R dash for which the Q factor that will be improved by 2 times. Then after example 7.23. A power transmission line feeds input power at 230 volt to a step down transformer with its primary windings having 4000 turns. What should be the number of turns in the secondary in order to get output power at 230 volt? Simple thing, VP, that is 300 volt. So primary supply voltage, number of turns in primary, that is 4000. Output voltage across secondary, that we want 230. So number of turns in secondary required, that we want to calculate. So VS by VP, that is NS by NP. So NS equal to NP into VS by VP. So 4000 into 230 by 2300. So we will get 400. Clear? 7.22, that is theoretical one. Answer the following questions. In any AC circuit, is the applied instantaneous voltage equal to the algebraic sum of the instantaneous voltage across the series elements of the circuit? Yes. Is the same true for RMS voltage? No. Because RMS voltage, that is the vector sum. It implies that when we calculate the RMS voltage at that time, we take under root VR square plus VL minus VC whole square. Clear? Then B question. A capacitor is used in the primary circuit of the induction coil. Here you have to remember this thing, that is to avoid the sparking. Actually induction coil તમારે હજી ભણવામાં ક્યાંય આવી જ નથી, રાઈટ? તો અહીંયા આગળ તમને એનો ખ્યાલ ના આવે કે એનું વર્કિંગ શું છે, કેવી રીતે વર્ક કરે. આખી સર્કિટ છે. ઇન્ડક્શન કોઇલ જે છે એ લો ઇનપુટ ડીસી એ તમને હાઈ આઉટપુટ એસી આપે છે, રાઈટ? પણ તમારે ખાલી અત્યારે યાદ રાખી લેવાનું. સી, an applied voltage signal consists of superposition of a DC voltage and an AC voltage of high frequency. The circuit consists of an inductor and a capacitor in series, so that the DC signal will appear across C and AC signal across L. So, see, capacitive reactance XC, that is 1 upon 2 pi FC. Now for DC, F is 0. So 2 DC, the resistance offered by capacitor, that is infinite. And therefore, the DC voltage drop that will be obtained across capacitor. Now, for inductor XL, that is 2 pi FL. And for very high frequency of AC, XL, that is large one. So inductive reactance is large one, means it offer large resistance to AC supply. So AC voltage drop that will be across inductor. Then D, a choke coil in series with a lamp is connected to a DC line. The lamp is seen to shine brightly. Insertion of an iron core in the choke causes no change in the lamp's brightness. Predict the corresponding observation if the connection is to an AC line. So if we connect it with AC line, in that particular case, the brightness that decreases. Why? Because the inductance that will increase, L increases, and therefore the inductive reactance of the circuit also increases. Then E, why is choke coil needed in the use of fluorescence tube with an AC mains? Why can we not use the ordinary resistor instead of the choke coil? Now we know this thing, if choke coil, after all it is coil, is used, then the power dissipation in it can be minimized, because in case of choke coil, the power factor cos phi that will be equal to 0, and therefore we use choke coil. And if we use resistor, then the dissipation of power in the form of heat will increase. So to minimize this one, we use choke coil. Clear to all of you?